Well, good morning, everyone. Hope everybody's day is going well. My name is Kim Schofield, and I am the State Pavement Engineer at Washington State DOT. And it's my pleasure to welcome you to the 5th session of this virtual National Pavement Preservation Conference. This session is focused on concrete pavement preservation and includes presentations by Mike Nelson, John Donahue, Kurt Smith, Linda Pierce, and John Roberts. Mike Nelson is a concrete engineer at the Indiana Department of Transportation Office of Materials Management. He previously was the technical services testing engineer in the Greenfield District, where he was responsible for quality control and quality assurance and material sampling, inspection, and testing. I am pleased to turn over the program to Mike Nelson.
Good morning, everyone. I'm going to be discussing partial depth joint repair that we've been doing in Indiana over the past few years. So the intent here is not to turn this into a training video. 20 minutes is not nearly long enough to cover the topic from a training standpoint. So I'm going to provide an overview of the repair method, talk a little bit about Indot's journey and our specification development, and then some lessons learned as we had progressed through the process over the last few years. The first thing I want to say about this is that this process started at MnDOT. They developed it, and they deserve full credit for having pioneered the process over 20 years or so. The second thing I want to say is that it absolutely does work. We've had success, and it does work, but the details absolutely matter. It's every patch, every time. If you don't follow the details, there's not much in between. These patches either really work or they really don't, but they do really work most of the time as long as you pay attention to the details. This is a shallow repair method. It focuses on the top half of the slab, and it is, we've proven we don't have to remove full slabs in order to have an effective repair and a good pavement. So it's been shown to be an effective method. It is a bit labor intensive. There's a lot of details and a lot of labor, but again, it is an effective method. The slide shows a little bit of our history. We placed our first patch. It was 400-foot long demo on the south side of 465 around Indianapolis in 2016. And that was our first stretch. Then we, for better or worse, kind of dove in with both feet. Our first project in 2017 was up there in the green circle on the left up near the Chicago area. That is one of our heaviest traveled corridors in the state. And, I guess we went all in for one reason or another. But you can see the green circles there. That Marion County, Indianapolis, that was certainly our, some of our highest volume traffic, as well as up in the Northwest. And then those other jobs are spread throughout the state. Some of those jobs spread multiple counties, but you can see the distribution of jobs for having one job or 3 jobs in 2017 to suddenly 54. You can see the process did balloon, and we were having success, so it progressed well. Slide shows the steps in the process. Picture 1 here, you will see that the process begins with a mill, and the intent is that you mill down around 2 inches. It's about 10 inches wide, and you take out the first pass, and then you expose what's underneath. It involves hand chipping, and there's no easy way to do it. It's hand chipping, and then there's an inspector who has to pretty much hit every linear inch of that thing or square inch of that with a hammer and determine that we've gotten all the sound material. We're down to sound material. And then it's a process of sandblasting and cleaning to ensure that we have gotten the rot out of there. And as you can see, it makes a bit of a mess down below. The joint isn't in too bad a shape. The second step involves, once the cleaning is complete, you're moistening and trying to achieve SSD there. The conditions at the bottom of the slot. We want a moist condition to bond the concrete to. This is high cementitious, very dry mix. We don't want to pull moisture out of the concrete, allow it to bond. Along those lines, we typically spread a grout in the bottom immediately prior to placement of the concrete. And then the concrete is placed, As you can see, it's fairly ugly concrete. It's stiff, 9-bag mix. It's placed, it's vibrated into place, then it is tooled to reestablish the joint, at least on the longitudinal joint. Transverse joints require establishment ahead of time. Then we have the grouting around the perimeter. This is an interesting step. The finishers you will find don't necessarily like this. It's broomed and then finished, and the final step is to make a sealing pass with that same grout around the perimeter. And we found that the finishers weren't happy about that because they like a nice pretty finish, but that's not the goal here necessarily. Last step is to place the grout, and then the very final step is the curing, which is curing compound, typically white as a sheet of paper. That is language we took from Indot. Specifically, it works. Kind of a funny moment when one of the foremen there said, or as white as your hard hat, but it gets the message across to the laborers that that's what we're trying to achieve. We also use what's called PAMS, polyalpha methylstyrene curing compound. Now, some of our first jobs, we have used wax-based curing compounds. We did use those successfully, but we have, our new spec has transitioned to a PAMS, which is what Indot uses, a more durable curing compound. But in a nutshell, that is the process. And it's worth mentioning here that we need to take a minute to talk about what we're really focusing on. What we're targeting is joint rot that is due to salts and chloride ingress into the joint. Jason Weiss, who was formerly at Purdue, helped us understand the mechanism and the calcium oxychloride formation that takes place due to salts interacting with the calcium hydroxide with the concrete. So the point here is that it is not focusing on some type of structural repair necessarily. This is primarily targets joint rot that is due to salt and just damage isolated at the joint, but it is not in any way intended to be a structural type repair. The first step in the process, and this is a little bit of a Monday morning quarterback approach, I guess, you want to select good candidates to start to have a successful project. Picture on the left was a city street, and you can see the joint looked kind of nasty at the beginning. There was asphalt in there. Obviously, it had problems, but when they milled it down, 2 inches there, you can see that the joint in the bottom of the slot is fairly tight. It looks good. It's just that top, the rot was in the top of the 2 inches there. So certainly a good candidate. Joint in the middle. This was our first joint repair on the south side of 465 we did in 2016. That was 3-4 inches wide at the top and pretty ugly actually. But once we milled down, and this was about 3 inches down, we plunged into mill. And then here at the center, this was about 6 inches deep, but the joint actually cleaned up fairly nicely. And this patch and repair is still performing well today. It was a successful candidate. Repair on the right is clearly a maybe. As I mentioned, this is not a structural repair, so you have to be a little worried about what's going on here in this area. Is this a single dowel maybe that was misaligned? If you just have one dowel, that can be removed. And this could be a candidate, but in general, this would be perhaps a question mark. I mentioned calcium oxychloride and joint rot and the mechanism. I guess the best advice I can give here is if we want to avoid the problem, Indiana now puts pozzolans in all of our pavements. The intent is to reduce the calcium hydroxide available. What we found was that this first joint we did, you can see that there's fly ash was in the pavement on the left side of the joint, the left side of the joint, and this was plain PCCP on the right. And you can just see the stark difference in what happened. So that right there was kind of testimony that just put the pozzolans in your pavement and we'll be a lot further down the road in the future. Likewise, we need to avoid the bad candidates. The picture on the left was from Gordon Brune and Indot, and that is not what we're targeting here. That is, the idea is not to weld two slabs back together that are fully gone. That slab is too far gone. Likewise, the slab in the middle here, there's something structurally happening here. Again, this could be dowels misaligned or something, but this is not really what you would be targeting And if you see this, these are typically more full depth repairs. Picture in the bottom right is of decracking. Now, we don't see much decracking in Indiana. My experience, that's somewhat or nearly eradicated. However, if decracking would not be a scenario where you want to use this, that pavement has a deterioration happening there that cannot be repaired in this way. The picture in the upper right was an interesting situation up on I-80, where this is actually not a bad candidate. They targeted and the field laid out the patch. They thought it was only one side of the joint. So what you see is they milled down on the right side of that joint. And you can see here at the top, it appeared to be fairly tight and not much visible. But when they milled down on the right side, you can see this concave nature of where the salts and chlorides, it was being eaten away. So the remedy here was they went back and ultimately did the repair on both sides of the joint. So it actually was a good candidate. You can see the joint was pretty good down below, but again, trying to visually assess this from the top is not easy. The right thing to do is to take cores. This is something we're still training our scoping folks. I get it. We have a pavement that needs to be repaired. We get different folks, so we just want to use it and get out there. But the best advice is to scope these things properly, take some cores and understand how good a shape or how bad a shape the joints are in prior to going down this path. Talk a little here about Indot specification. Our goal, as I mentioned early on, was that we knew when we sat down to develop this specification that other states had tried this and tried to emulate what MnDOT had done, and everybody was not successful. And so our goal when we went into this was to try to do and follow as closely as possible what MnDOT has done. We did focus on longitudinal joints, transverse joints, and corner breaks. The items, if you look at our spec, we call them joint repair partial depth and joint repair bottom half. The MnDOT specification does include crack repair, so the method can be used for that, but we were kind of limiting our focus and trying to have some success. So we started only with the joints, and that's still where we are. We have not added crack repair to our spec. Our specification does pay by the square foot. MnDOT has a bit of a hybrid where depending on the length, they will pay some by linear foot, some by the square foot. Share more here in a second, but Indot, we did add more mix options. And I think I don't want to overstep or overspeak, but I believe we've got more mix options than what MnDOT typically uses. This is the list of mixes that we have. This mix, what we call OPC, ordinary Portland cement-based concrete. This really is what the MnDOT specification calls 3U18. That is their spec designation for this concrete mix design. It is a 9-bag mix that's basically a 50-50 blend of a coarse ag, which is 3/8 quarter-inch material, and sand. And it's a very high cementitious, stiff mix. But this is what the specification is written around, is this mix. Mix A is what we call prepackaged concrete patch material, or CPM. But what that is there's a producer in Minnesota area that they decided to take the dry materials that would create this mix, the 3U18, and basically they put the dry components in a bag. So the 3U18 material, CPM material from the company, is simply the aggregates and cement in the proper proportioning for MnDOT's 3U18, and it's sold as a bagged material. There's a newer version of this called 3U58 that actually includes an air entraining admixture and a super plasticizer in the bag. It makes life a little easier. And we initially did not use that because we were concerned about control of the air content, but we have since had contractors use it. We've added it to an approved list, and it works. It is a little more, has a little higher slump and perhaps a little easier to work with than the 3U18, but both products are successful and can be used just fine. Just with the 3U18 bag material, you have to add your own admixtures. Options B and C, we do not really see them used very often simply because these require bulk control of the aggregates. When we developed it, we kind of thought this is what would happen. But ultimately, the bagged materials have proven to be the go-to products. Likewise, we at Indot added LMC and LMCVE. Some contractors have gravitated towards using mobile mixers as the means of delivery. That has worked as well for us also. And we've had a couple of jobs where they were fast track jobs where we actually closed the interstates in some pretty high profile jobs. And typically these would be a little expensive, but these are usually what we would use for perhaps bridge deck repair and just fast patching. And they did use those products exclusively on some jobs around 465. So all four of these, we've seen success with all of them. The mixes C, E, and F would be the only ones that would be considered truly your rapid set options. And we originally were looking at doing our first job in overnight scenarios, but we have actually not really dealt in any true overnight, closing at 9 p.m. and opening at 6 a.m. type scenarios. Each mix is unique. The grout to not to grout or the curing methods tend to be a little bit unique for each mix design. Indot standard drawings, these are new to, we've finally got these finished, but you can see here the idea is that we show the trapezoidal mill to remove the initial material. The hand chipping happens later. This was something we finally concluded that this is for a transverse joint, and it's absolutely imperative that you preserve the movement of the joint and reestablish the compression relief of a transverse joint. This is something that there was a learning curve because folks would work on longitudinal joints, and we had some jobs that were primarily longitudinal, which those are non-working joints. And then when they started working on transverse joints, they didn't necessarily fully understand the movement. So we are training the folks who are involved in the labors to understand this. Took a little bit of time, and it's constant care to make sure they fully understand. But in our detail, we went the route of recessing, requiring them to recess the compression relief material. Early on, if you remember on the picture I showed earlier where the bottom of this area here that was milled off was very flat, there's nothing to really key in that compression relief material. If you do not do that, the risk is that your mud can flow underneath and it will lock up the joint. So that will cause problems. This is a key characteristic that we've established. Some people will come back and say, can we just solve for separation to reestablish the joint? That gets a little dicey because the depth can be variable and it's hard to tell the saw guy to saw until you feel you're already all the way through it. So this seemed to be the most foolproof way to create that joint. Some lessons learned. Training is an absolute must. There are some things that are not intuitively about the nature of this process. And again, every patch, every time, but you've got to get some training. As I mentioned, the longitudinal joints are a bit more forgiving because they are not working joints. And we had a job kind of go bad on us that dried grout certainly is a bond breaker, not a bonding agent. And if that dries out, it absolutely has to be removed, which is clearly stated in the spec. Be careful with gaps. I know money on patching jobs is not infinite, but it's a bit of a short-term gain, long-term loss to jump over short areas. You can see here that this may have looked worse at the time, but you can see things are happening here. This was an interesting case where on I-80, you can see 2.5 years later where they patched here and here, but obviously this didn't look so bad at the time, but I don't think this is something they really would have had they known what it would look like 2.5 years later. So, be careful with skipping short stretches, save money. We learned here that going too far beyond a patch or just a little bit beyond a patch is not, or a joint is not good. So we're saying you need to either go, like a foot past or stop a foot short. Finally, the goal here with the transverse joint is to ensure that the concrete does not flow underneath the compression relief material and create a bridge like this. You've got to make sure you've got that well recessed and you're not getting mud to flow underneath the joint that will lock up joints. Lastly, this was a weather issue. Our specification says 50 degrees and up at the time of placement. You might be a little more forgiving during warmer temperatures in the fall, depending on where you're at in the country. But once you really start to lose the heat of the season and your slabs become a block of ice, you just do not have a lot of depth here and a lot of mass to generate its own heat. This was a case where we tried the actual rapid setting LMC, very early strength. They placed it, in some 40 degrees and came back the next day and it was goo. Blankets aren't going to help. So it is limited by the season and the temperature. As I stated, MnDOT has done wonderful things developing a process, and I think we've been successful in Indiana to emulate what they've done, and we're going to continue on with the process. So thank you for your time.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.